Hello everyone. In this lesson, we will discuss series RC circuits. Take a look at these circuits that are given for us right here. And we have a DC voltage source, and we connect a resistor and a capacitor. So these two components are connected in series to the source. So this is called the DC RC series circuit. Okay, so in this case, the purpose is we are charging the capacitor in this case. Alright, so if a circuit contains a resistor and a capacitor in series with the voltage source, this one is called a series RC circuit. So the main function for this capacitor is it acts as the temporary voltage source. So let's say if I close the switch, then it means that I generate the current going through this. So when the current going through this, it will charge this capacitor. So at the time t equal to 0, it means that the switch is open. Then the voltage across this capacitor could be equal to 0, right? Because you haven't charged it yet. And if I close the switch, it means that I get the current going through the circuit. When the current going through this capacitor, it starts charging this capacitor, and I create a voltage difference across this capacitor. So let's talk about voltage in this case. Okay, so if we talk about voltage, then because the resistor and the capacitor, they are connected in series with each other. So according to Kirchhoff voltage law, the voltage across this resistor adding the voltage across this capacitor could be equal to the voltage source. So in the way that the voltage drop across this resistor right here. So if I want to label this as VR, and I measure the voltage across this capacitor, so I label this one as VC. Okay, so in this case will be my VC. Then it means that E equal to VR plus VC. So the voltage across your resistor adding the voltage across your capacitor, the sum of it will be equal to the total voltage source. So keep that in mind. Okay, so now at the time t equal to 0, the voltage across the capacitor could be equal to 0 as well, because there's no current going through, so I'm not charging this capacitor to create a voltage difference across this capacitor. But as time increase, that means that I close the switch. With time increase, the current going through this will charge this capacitor. Okay, so we will charge the capacitor, and at any time, the voltage across the resistor will have to be calculated by these formulas. Okay, so these formulas is the voltage across the resistor will be equal to the total voltage source multiplied by the number E raised to the exponent of negative t divided by r times c. So don't forget, negative t divided by r times c is the entire exponent for this number E. Okay, so let's repeat this concept. Okay, at the time t equal to 0, Vc is equal to 0, so it's very obvious. Then, according to Kirchhoff voltage law, the voltage across the resistor will have to be equal to the voltage source. So then I'm going to close the switch, and then I am going to generate the current going through this. It means that the voltage in my source remain the same, but now it will have to distribute among the resistor and the capacitor, right? So therefore, the voltage across the resistor will decrease to make the increase in the voltage across this capacitor. So in that process, for me to calculate the voltage across this resistor, I have to use this particular formulas. Okay, and this formulas is again, like I mentioned in previous lesson, this formulas we can prove or we can derive it using a complicated process in calculus, using a differential equation involving derivative integration, but we are not going to work with that in this class, so I just have to tell everyone the formulas. All right, okay. So our purpose is to take a look at these formulas and perform order operation to calculate certain components that they asked us to calculate. Okay, so and we know what number E is the irrational number. And one thing I would like everyone to note is this. Okay, so this part, uh, I mean the exponent of E. The exponent of E is negative T divided by R times C. Okay, so take a look at this. Your time is always equal to the second. It's the time domain, right? So we are talking about time, that means in second, minute, hour. But then underneath this, like as a denominator of this fraction right here, you have a resistance multiply a capacitance. So you have resistance measured in ohms, capacitance, excuse me, capacitance measured in um, farad, right? So you have ohms multiply farads. So what do you get out of that? So in order for you to have a proper unit for this particular exponent so that you can apply to the E to that exponent, R times C is defined as time constant. Okay, so if you take the value of your resistor, you multiply the value of your capacitor, or resistance multiply capacitance, ohm times farad, in this case defined as second, time constant. Okay, so keep that in mind. Okay, so that the value that you divide into the time will cancel out the unit, and you take that number as the exponent of your E. Therefore, in many of the process how to calculate certain components, or calculate VR, which is the voltage across the resistor, or calculate the times here, I always recommend everyone to find your time constant first, which is the denominator of this exponents right here. Okay, so let's work with the example. Example 1. In charging a series RC circuit, so now you know that charging it, that means I turn on the switch so that I can gradually increase the voltage across the capacitor. Doing that, I will gradually decrease the voltage across this resistor so that when I add the voltage across the resistor with the voltage across the capacitor, I maintain the same voltage source. Okay, the value of the voltage source. So don't forget, this is just an example, um, and I may not have the real values here for any of these components, so we just want to make sure that we know how to practice with the calculation in this particular formulas. Okay, so this example associated with this formulas right here. So in charging a series RC circuit, E is given as 50 volts, R is 100 ohms, and a capacitor, I have a 0.001 farad, and I want to find the voltage across the resistor at the time t equal to 0.05 seconds. So I just want everyone to remember that I am putting everything in 3 significant digits, because at the end, the question asks us to present our answer in 3 significant digits as well. Okay, so see step 1, as I mentioned earlier, I always try to find my time constant first. So after I got my times constant as this, okay, take 100, multiply these values, I end up with 0.1. Okay, so you are working with just the unit ohms and farad, so you are having just a second here. So if you use your calculator in engineering notation, it will give you back a value in engineering notation. Okay, so then you see I take 0.0.5 given for me as t, so this is the negative t. So 0.05 divided by 0.1, I should get 0.5 as the answer with a negative. So now your next step is to take 50 and multiply e to this exponent negative 0.5. If you use a calculator, it should be equal to 30.3 volts in 3 significant digits. So let's get to our calculator, and hopefully I can quickly show everyone how to get this. Okay, so anyway, I still need to erase this part from my previous lesson. Alright, okay. So what we need to do is we need to calculate VR at this point. It would be equal to 50 times e to negative 0.5. Okay, so we are going to key in. I key in 50. So 50. So it will be 50. And then to be safe, I will click the multiplication sign. So I will put multiplication. And then I press shift. Right? So you know shift here. And then I press the long key. Because press the long key, I will have the value e like this. So e will be like that. So then I raise that to the exponent negative 0.5. So I will press the negative sign. Alright. And then you key in 0.5, negative 0.5, and press equal sign to see what we get. Yes. And we are getting 30.3265. Okay, so 30.3265, 3299 on our calculator, but I just want to write a few decimal places here. So in order for us to round to 3 significant digits, so this is your third significant digit. So that means you have to look at the 2. So 2 is less than 5. Therefore, your final answer should be 30.3. In this case, it's just volts. So let me go back to our handout. Okay, so we have to have a handout. Okay, so therefore you see right here, I have our answer as 30.3 volts in 3 significant digits. Okay, so some of you may want to make this calculation all at once. So you can go ahead and do that. So you can want to key all this into your calculator at once. If you do that, then you make sure that you go 50 e a negative, but you must put this in the brackets, okay? Yeah, put that in the bracket, then you should be okay. Without putting all of this in the bracket, you will have an error. Okay, so, and honestly, I always recommend everyone to find this times constant right away, so that it simplifies the calculation. It also simplify the error, like eliminate potential error. That's what I mean. Okay, so let's move on to our next example. So this one we will do the reverse. Okay, so if we do the reverse, that means we are going to find time instead of finding the voltage across the resistor. So I think it's a good idea to write our equation down. So I will have VR equal to the voltage source multiplied by the number E raised to exponent negative t divided by the time constant R times C. If we are talking about the RC series circuit in this case, right? Okay, so this question asks me to, in charging a series RC circuit, E is given as 50, resistor as 200 ohm, capacitor is 0.1 farad, find T when I is equal to 0.45 0 amps. So I'm given a current in this case, okay? So I need to find the time. Okay, I need to find the time. So don't forget, time is now the unknown, and it is the exponent, right? So unknown involving the exponent. Therefore, you know that in our previous lesson, if everyone recall, that if you are solving for an unknown as the exponent in an equation, then the operation that you should think in your mind is using logarithm in order to solve it. In this case, because of you have the e here, so we are going to work with natural logarithm. Okay, so you see the very first step I recommend to everyone is to find the time constant RC. So you take R, you times C, you will have the answer as 20 seconds in this case. So you identify this as a second because it's a time constant. Okay, so now because you are given I and you don't have R to work with, so we are going to use Ohm's law, right? So Ohm's law telling me that if I take Ohm's law is E equal to I times R, right? I times R, and I am having I, right? I'm having E. If I take these two values, I multiply with each other. I mean R. I'm sorry. So I'm giving I and I'm giving R. So if I take this R values, I multiply with the current, I can figure out the voltage across that particular resistor R. So from here, I can see VR will be equal to I times DR. So the voltage across this resistor at certain point will have to be equal to this. So take I times R, I will have the voltage across this resistor R as 9 volts. Okay, then since time build up in this case, the capacitor will affect the voltage across this resistor. So eventually, the voltage across this resistor will not be equal to 9 anymore because it has to be distributed to that voltage across the resistor, the voltage across the capacitor. All right? Okay. So let's plug in the number. So now VR equal to 9. You see, I put in VR equal to 9. The total voltage source equal to 50, and that's the E, and the negative T that you have to look for, and 20 is coming from the time constant that you already calculate. Okay, so at this point right here, I would like to ask everyone that remember when you solve for an equations, whatever you do, you perform some sort of operation on this side, you do the same thing on the other side. So in this case, I divide both sides by 50, right? So 9 divided by 50 equal to 50 e to the negative t over 20. I divided by 50 as well. So that means that cancel out. And I just have e to the exponent negative t divided by 20 on this side. And you see the 50 is going to the other side. Or in advanced mathematics, we can say that you multiply by 50, bring it across your equal sign, you have to change to opposite the operation. That means you divide it by 50. So 9 divided by 50, I have 0.180. Okay, so this step is very important, everyone. I really want everyone to note this. This step is actually very important. Why I am saying that? Because you don't want to make any error involving your logarithm. Okay, when you take logarithm, is quite complicated unless you are having just one number on this side of your equation and just one component on the other side of your equation. Okay, so if you leave one or two components on each of this side and then you decide to take logarithm, then you have to apply property of logarithm. Okay, so let me go back and show you what we have done. Yes, okay, so this question, this handout right here, I asked everyone to take a look at this, right? So note this. Okay, so if you take logarithm of the two components are multiply with each other, you have to break them into two. You have to apply this sum of the two log. So if you divide it by, you have to apply the difference of these two log. You don't want to run into this concept. Therefore, you need to make sure that you have just one single log on one side of the equation and then the single log on the other side of the equation. So there. So right here I have just one number and equal to that. So I take natural logarithm of 0.180 and at the same time I take natural logarithm of e raised to this exponent. So because we mentioned that logarithm is an operation, right? It's an operation using your calculator. So whatever operation you apply for this side of the equation, you have to apply the same operation on the other side. Alright, okay. So log of 0.180 is easy to find using our calculator, but take a look at this one. Okay, so you have this part right here. So I would like everyone to pay attention to this part of the equation. You have log of e raised to the exponent of negative t over 20. So using this formula that I explained to everyone earlier, that if you have log of e to the exponent x, it's just equal to x. That means you can eliminate the log of e here, and the other side of your equation will equal to just the exponent of this argument, right? So the argument for this natural logarithm on this side is e raised to the exponent of negative t over 20. So basically, it's like this. Okay, so I can break that into log of e to the e of negative t over 20. And this whole thing here is the exponent of this entire log. So that eliminate, right? So this, you can cancel it out, and it's just equal to the exponent. So the other side equal to negative t over 20. So you see, your equation now simplify more further to the step where you just perform order operations, or you can very simple to solve for t in this case. So now the unknown turn into the unknown in a linear equation. That's what I mean. So it's not an exponent anymore. So logarithm is the process that when you apply logarithm, your unknown is not an exponent anymore. Your unknown is just the numerator of this fraction on this side of the equation. So you can simply solve for this simple linear equation. Okay, so if you punch this into your calculator, natural logarithm of 0.180 is equal to this value, which is negative 1.714798. You see, I keep quite a few decimal places because I have to round to 3 significant digits at the end. So the more decimal places you keep, the better accurate your answer. So then I have on the other side equal to this, right? So you can multiply this over to the other side of the equation, and you can apply the negative sign to that, and in the end I should have t equal to 34.3 seconds. Okay, you see the negative in front of the t can also apply to the 20. So this mathematically, okay, is negative 0.714798 will be equal to t divided by negative 20. So that's what I mean, okay? So mathematically, this negative can apply to this negative 20 as well. And you multiply both sides by negative 20 to get rid of this. So therefore, I have multiplication of negative 20. And in the end, my answer for time is a positive value, 34.3 seconds. If you ever end up with the negative value for t, which is incorrect, right? Because time can have to be a positive, like after, it means that after 34.3 seconds, okay, you will actually charging your capacitor and decrease the value from the voltage across the resistor in this case. Alright, okay. So basically, I would like everyone to remember that follow order operations, right? Also, make sure that you find the times constant first. Substitute into your formulas here. VR equal to E times E to the negative T over the time constant. So simplify to the number as a denominator first, because you don't want to perform too many operations here using your calculator. And at this point, I divide both sides by 50. And the main point is to get just one components on this side of the equation equal to just one component in the other side of the equation. Then you can take natural logarithm on both sides. You don't want to run into using property of logarithm, so having the natural logarithm on both sides, that means on this part of your equation you can eliminate the ln e, and the right hand side just equal to negative t divided by 20. So this is a very simple linear equation to solve for, and at the end perform the very basic operations of mathematics. Your skill in solving for linear equation, you should have the answer as 34.3, round to 3 significant digits. Okay, so using your calculator, make sure that you get the number and then check the answer that I have here for everyone. And also, I want to remind everyone that in most of this question that I gave you, the answer for time is always a positive value. Because if you end up with a negative, you know that is incorrect, because you have to increase the time in order to obtain a certain voltage across your capacitor. So I only have a few minutes left, but I really want everyone to try the exercise that listed here. Okay, and right here you see I have kilos, I have micro, and I have milli as the answer. So I would like everyone to turn on your engineering notation mode on your calculator. If you work with Casio FX991MS, you know how to turn your engineering notation on. And all you do is just key in, using your engineering notation to key in the kilo, the micro, so that you can get the answer in engineering notation as well. Okay, and don't forget to round to 3 significant digits. And I do have the answer here for everyone to work with. And if I give you the question where I give you the VC, okay, give you VC, then you make sure that you are finding time t for the voltage across the uh, resistor. Then you make sure that this VC will have to be take away from your total voltage source so that you can find your VR. Okay, so let me show you where the solutions are. So on the same handout, if you go to this page, okay, so starting on page 5, you see all the solution is actually typed out for everyone. So I don't think I need to go over this. All the steps are very clear. So you can go ahead and work on that, and then make sure that you check the solution. Alright, thank you everyone.